According to NEC Section 358.30, electrical metallic tubing or EMT must be securely fastened. Tie wire is an acceptable method of fastening EMT as it provides a secure and economical way to hold the pipe in place. However, it is important to use the correct size and type of tie wire and to install it properly. The most common type of tie wire used for EMT is galvanized steel wire. The wire should be at least 12 inches long and 1/16 inch in diameter. It should be wrapped around the EMT in a figure-8 pattern, and the ends should be twisted together and cut off. Tie wire should not be used to support EMT that is subject to vibration or movement. For these applications, a more secure method of fastening, such as EMT straps or hangers, should be used. In general, tie wire is a legal and acceptable method of fastening EMT, provided that it is used properly. However, it is always best to consult with the local building inspector to ensure that the installation is up to code. Let's delve deeper into the requirements and best practices for using tie wire to secure EMT conduit. Firstly, the National Electrical Code, or NEC, provides the overarching guidelines for electrical installations. While Section 358.30 mandates secure fastening, it doesn't explicitly prohibit the use of tie wire. This means that tie wire can be a compliant method if it meets the general requirement of securely supporting the EMT. Secondly, understanding what constitutes a secure fastening is key. This depends on several factors, including the size and weight of the EMT, the spacing between supports, and the environmental conditions. For smaller EMT runs in protected locations, tie wire may suffice. However, for larger conduits or installations in areas prone to vibration or physical stress, more robust support methods are necessary. Thirdly, the material of the tie wire is important. Galvanized steel wire is the most common choice due to its strength, durability, and resistance to corrosion. Using other materials, such as uncoated steel wire, could lead to premature rust and failure, compromising the security of the installation. Fourthly, the dimensions of the tie wire matter. The suggested minimum length of 12 inches and diameter of 1/16 inch provide adequate strength for most common EMT applications. However, for heavier or more demanding installations, a thicker gauge wire may be required. Always err on the side of caution and choose a wire size that can comfortably support the conduit. Fifthly, the figure-8 wrapping pattern is crucial for distributing the load and preventing slippage. This pattern ensures that the tie wire grips the EMT firmly and evenly, minimizing the risk of the conduit coming loose. Improper wrapping techniques, such as simply looping the wire around the EMT, can lead to instability and failure. Sixthly, twisting and cutting the ends of the tie wire properly is essential for safety and aesthetics. Twisted ends should be tight and secure to prevent the wire from unraveling. Cutting the ends cleanly minimizes the risk of sharp edges that could cause injury. Seventhly, consider the limitations of tie wire. As mentioned earlier, it's not suitable for installation subject to vibration or movement. In these cases, EMT straps or hangers provide a much more secure and reliable support. These devices are specifically designed to withstand dynamic forces and maintain a firm grip on the conduit. Eighthly, when using tie wire, ensure that it's compatible with the supporting structure. For example, if the EMT is being supported by metal studs, the tie wire should be securely fastened to the studs using appropriate methods such as screws or clips. Avoid simply wrapping the wire around the studs, as this can be unreliable. Ninthly, pay attention to the spacing between supports. NEC Table 358.12 specifies the maximum allowable spacing for EMT supports, which varies depending on the size of the conduit. When using tie wire, ensure that the supports are spaced closely enough to prevent sagging or excessive stress on the wire. Tenthly, always consult with the local building inspector or electrical authority to ensure that your installation complies with all applicable codes and regulations. They can provide valuable guidance and help you avoid costly mistakes. 11thly, consider the long-term performance of tie wire. Over time, exposure to environmental factors such as moisture, temperature changes, and chemical fumes can degrade the wire and weaken its grip. Regularly inspect the installation and replace any tie wire that shows signs of corrosion or damage. 12thly, explore alternative fastening methods. While tie wire can be a cost-effective solution, EMT straps, hangers, and other specialized fasteners offer superior strength, durability, and ease of installation. Consider these options, especially for critical or demanding applications. 13thly, document your installation. Keep records of the materials used, the support spacing, and any other relevant details. This information can be helpful for future maintenance or modifications. 14thly, be aware of industry best practices. Consult with experienced electricians or electrical contractors to learn about their preferred methods for fastening EMT. They can share valuable insights and tips that can improve the quality and reliability of your installation. 15thly, consider the aesthetic aspects of your installation. While tie wire can be functional, it may not be the most visually appealing option. EMT straps and hangers provide a cleaner and more professional look. 16thly, prioritize safety. Always wear appropriate personal protective equipment, such as gloves and eye protection, when working with tie wire. Sharp edges and loose ends can pose a safety hazard. 17thly, use the right tools for the job. Wire cutters and pliers are essential for properly twisting and cutting tie wire. Avoid using makeshift tools that could damage the wire or cause injury. 18thly, consider the grounding implications. Ensure that the EMT is properly grounded in accordance with NEC requirements. Tie wire should not be used as a substitute for proper grounding connections. 19thly, be mindful of the potential for galvanic corrosion. When dissimilar metals are in contact, such as galvanized steel tie wire and aluminum conduit, corrosion can occur. Use compatible materials or take steps to prevent galvanic corrosion, such as applying a protective coating. 20thly, always follow the manufacturer's instructions for any EMT straps, hangers, or other fasteners that you use. These instructions provide important guidance on proper installation techniques and load ratings. 21st, consider the impact of your installation on other systems. Ensure that the EMT and its supports do not interfere with other electrical, mechanical, or plumbing systems. 22nd, be aware of the potential for thermal expansion and contraction. EMT can expand and contract with temperature changes, which can put stress on the supports. Use expansion fittings or other methods to accommodate this movement. 23rd, consider the accessibility of the EMT for future maintenance or modifications. Ensure that the supports are positioned so that the conduit can be easily accessed if necessary. 24th, be mindful of the environment. Avoid using tie wire in areas where it could be exposed to corrosive chemicals or extreme temperatures. 25th, always double check your work. Before energizing the circuit, inspect the EMT installation to ensure that it is secure, properly grounded, and in compliance with all applicable codes and regulations. 26th, remember that the NEC is a minimum standard. Consider exceeding the minimum requirements to provide a more robust and reliable installation. 27th, stay up to date on the latest code changes and industry best practices. The electrical industry is constantly evolving, so it's important to stay informed. 28th, consider the life cycle cost of your installation. While tie wire may be a cheaper option upfront, EMT straps and hangers may offer better long-term value due to their durability and reduced maintenance requirements. 29th, be aware of the potential for theft or vandalism. Secure the EMT and its supports to prevent unauthorized removal or damage. 30th, document any deviations from the NEC or industry best practices. Obtain approval from the local building inspector or electrical authority before making any deviations. 31st, consider the impact of your installation on the overall building design. Ensure that the EMT and its supports are integrated seamlessly into the building's architecture and aesthetics. 32nd, be mindful of the potential for electromagnetic interference. EMT can shield electrical circuits from electromagnetic interference, but it must be properly grounded to be effective. 33rd, consider the use of color-coded tie wire to identify different circuits or systems. This can simplify future maintenance and troubleshooting. 34th, be aware of the potential for condensation to form inside the EMT. Use sealing fittings or other methods to prevent moisture from entering the conduit. 35th, consider the use of flexible metal conduit or FMC in areas where EMT is difficult to install or where flexibility is required. FMC can be easily bent and routed around obstacles. 36th, be mindful of the potential for static electricity to build up on the EMT. Use grounding straps or other methods to dissipate static electricity. 37th, consider the use of strut systems to support multiple runs of EMT. Strut systems provide a strong and versatile platform for supporting conduits and other electrical equipment. 38th, be aware of the potential for rodents or other pests to damage the tie wire. Use rodent-resistant materials or take steps to prevent pests from accessing the conduit. 39th, consider the use of fire-rated EMT and supports in areas where fire protection is required. Fire-rated EMT and supports are designed to withstand high temperatures and prevent the spread of fire. 40th, always prioritize quality over cost. Using high-quality materials and proper installation techniques will result in a safer, more reliable, and longer-lasting electrical system. 41st, continuously seek to improve your skills and knowledge. Attend training courses, read industry publications, and learn from experienced electricians to become a more competent and confident electrical professional. 42nd, be a mentor to others. Share your knowledge and experience with apprentices and junior electricians to help them develop their skills and advance their careers. 43rd, always uphold the highest ethical standards. Be honest, fair, and respectful in all your dealings with customers, colleagues, and suppliers. 44th, be a responsible member of the electrical community. Support industry organizations, participate in code development efforts, and advocate for safe and reliable electrical installations. 45th, remember that electrical work is a serious responsibility. Your actions can have a significant impact on the safety and well-being of others. Take pride in your work and always strive to do your best. 46th, when in doubt, seek expert advice. Consult with a qualified electrical engineer or inspector to ensure that your installation is safe and compliant. 47th, never compromise on safety. If you are unsure about something, stop and ask for help. It's better to be safe than sorry. 48th, always be prepared for emergencies. Keep a well-stocked toolkit and a first aid kit readily available. 49th, be aware of the potential for electrical hazards. Work safely and always follow proper lockout/tagout procedures. 50th, never work alone. Always have someone nearby who can assist you in case of an emergency. 51st, be respectful of the environment. Dispose of waste materials properly and avoid polluting the air or water. 52nd, be a good neighbor. Minimize noise and disruption during electrical work. 53rd, be thankful for your job. Electrical work is a rewarding and challenging profession. 54th, always be learning. The electrical industry is constantly changing, so it's important to stay up to date on the latest technologies and techniques. Tie wire, when properly used, provides a simple and economical fastening method.